Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the derivative of the trigonometric functions. So before going to the problems, we will just know what is the derivative we are using the trigonometric functions. So y and y prime, that is dy over dx. What is the derivative of sine x? So which is equal cosine x. Cosine x is equal minus sine x, and then secant x. So here secant is secant tan, and tan x, which is secant square x. Similarly, we will have a combination of cosec and cotan. Cosec minus cosec cotan, and cotan x, which is minus cosecant square x. So this
I'm
is what we
sorry,
all
but
have
I can't.
now. So these are the trigonometry derivative functions. So formula, and here there is a note: limit x approaches to 0, sine theta over theta is equal 1, and limit x theta approaches to 0, cosine theta minus 1 over cos theta is equal 1. We are going to use this formula to solve the problems. And here this is a very important identities we are using in our problem to simplify the trigonometry function using this identity. If you know this one, you can deduce the two formula: fix the sine square one side, move the cosine that side, you will get this rule. And similarly, fix the cosine here and move the sine square, you will find it the another formula. So this is the three important identities we will use in the problem. Let us go with the first problem here. So the first one is the differentiate f of x. So here f prime, I use the f prime of x is equal. So here it is c, 3 is a constant like a c into f of x. So you have to make it constant. So this is a constant. What is the derivative of sine, which is equal cosine x minus 2 is a constant here. What is the derivative of cosine, which is minus sine? So it becomes minus of minus plus, it is sine x. Therefore, the value is f prime of x is equal 3 cosine x plus 2 sine x. That's it. The next one here, we will have the product rule. We have to use the product rule because it is f into g. So this is f into g. H prime of theta is given by, so I write it the rule fg plus fg. So the rule will be f prime or the g prime. Now I have to differentiate this part, and this is fixed, plus, and theta square is fixed. You have to differentiate the g. So what are the derivative of f? This is 2 theta. Here the variable is theta. It like x, you can assume it as x. Now here sine theta differentiation is cosine theta, and then h prime of x equal 2 theta sine theta plus theta square cosine square. So this is the final answer. Now whereas see this one, what are the difference between this problem and this problem? Since it is a product of two functions, that's why we are using the product rule. Whereas here it is the separate term, so you can use directly the linear property. So h prime of theta is equal, see here, this is 2 theta plus, due to plus this is separate term, so what is the differentiation of sine? It is cosine. That's it. So when you have a product, you have to use the product rule. Now the next rule here, it is the f of x. So when you do the first derivative, you have to use the f into g. So what is the rule here? Fg plus fg prime. So it is the rule. So I will apply this part. So what is this here? So e power x is fixed, e power x differentiation, and sine is fixed. Okay, plus e power x is fixed. What is the differentiation of sine? It is cosine. This is done. Now the first part is over. This is the derivative we have done. And the last one is as it is. What is the derivative of cosine? Which is minus sine. Minus into plus, which is minus sine. So this is the f prime of x. You can take you cannot take the e power x as a common because there is no e power x here term. So leave it as it is. So the final answer will be e power x sine x plus e power x cosine x minus sine x. So leave it as it is. If you want to take the common factor, you can take the common factor for only two term, first two term as a e power x. But here there is no e power x common. Now let us go with the next one. Here it is a product of three functions. See f, g, this is h. So I use the rule first. This is f, g, h, f, g, h, f, g, h. So here f prime, g prime, h prime. So what is the derivative? F prime of x given by, yes, the first one, these two is fixed. So x e power x is fixed. So what is the derivative for the first term, which is 2x? First is done. What about next? X square is fixed, e power x is fixed. What is the derivative for the sine x? That is cosine x. Next, plus x square fixed, sine x fixed. What is the derivative for e power x, which is e power x? And by the way, here e power x is common in all the terms, which is there in all the terms. So we can take e power x as a common factor. But in the last problem, we cannot. Because in the last term, you don't have e power x. So 2x e power x, or you can take the x also common. So you can take the x also common. So you will get 2 sine x for the first term plus x cosine x plus x sine x. This is the answer. Now the next rule here. So quotient. So here it is f over g, but it is a trigonometry functions are there. So this is f over g. So what the rule we have? G square, g fixed, f prime, f fixed, g prime. This is the y prime. Now y prime is equal whole divided by 1 plus cosine theta whole square, 1 plus cosine theta. And what is the derivative for f, which is cosine x, and then minus sine x will be fixed. What is the derivative for the denominator? 1 becomes 0. Cosine is minus sine. Minus sine. Now thereafter it is a simplification. What is the simplify here? We have to simplify this part. So this is y prime is equal, multiply this one inside. So you will get cosine theta plus cosine square theta. When you multiply these two, you will get minus of minus. It becomes plus sine square theta over 1 plus cosine theta whole square. But we know the identity. Using the identity, so sine square plus cosine square is equal 1. So that's why the identity is very useful. We are using this one to simplify the trigonometry function. Therefore, cosine theta plus 1 over 1 plus cosine theta whole square. This is the same term you have. So I will cancel this part one time. So 1 plus cosine and cosine theta plus 1, it is same. So the final answer will be 1 over 1 plus cosine theta. So using the identity only you can solve the problem. Now the next one we have here, it's the limit of the function, we are make use of these nodes. So we make use of this node. So we will take this part and we will paste it here so that we will refer. Now here, as per this rule, I have to get it the same term. So I have to get it the same term. 7x means it should be 7x in the denominator. Then only you can apply the rule as sine theta. I write it the rule first here. This is the rule. In order to apply the rule, we will have limit x approaches to theta approaches to 0, sine theta over theta is equal 1. So it should be the same term you will have. If it is theta, it is theta. If it is 7 theta, 7 theta. 4 theta, 4 theta. But it is not the case. So I can just make an adjustment here. So I will take the 1 over 4 outside because it's a constant. We can take it outside the limit. Then sine 7x over x. So this is what you will get. This is the same thing, just I am taking the 4 outside. 4 is a outside. 4 is outside. This is what we have. Now I make an adjustment. I multiply 7 and I divide 7. Why we are dividing 7 particularly? Because I need this part. That's why I make it 7 here. So if you divide 7, I have to multiply the 7 in order to balance the equation. Now as per this result, therefore this become 1. So as per this result, this is equal 1. So the answer will be equal 7 over 4 into 1, which is equal 7 over 4. 7 over 4. Now we'll take now the next problem we will take here as the same thing, but so we will use both the rule here. So what is the rule we will take here? So limit x t approaches to theta approaches to 0, cosine theta minus 1 over theta is equal 1, and cosine theta 0 sine theta over theta is equal 1. So these both results we are going to use in this problem. But the problem is here, in order to apply this rule, there is a shortage of theta in both the terms. So for that one, I will make use of this one. Limit theta approaches to 0. This is cosine theta minus 1 over limit theta approaches to 0 sine theta. We can apply the limit to the numerator and denominator. I have to make an adjustment in such a way that it should be equal to 1. I want to use the rule. For that one, I divide by theta here. I divide by theta here. So if you cancel, you will get the same thing. Now for the numerator, the entire part is equal what? Equal 1 as per the note. And this is equal 1. So therefore the value will be equal 1 over 1. So answer will be 1. Now the next one here, it is cotan x. Cotan x. So what is the cotan x here? So limit x approaches to 0. X cosine x cotan. Cotan means what? It is cosine over sine. So we cannot use the cosine theta rule. So I can use only this rule. I can use only this rule. How will you use? So this is the thing, you have a limit. So I can bring it down this part. Limit x approaches to 0. This is cosine x over sine x over x. Is it right? So this you can write it like this one. So the same thing, the x goes to the numerator. Now apply the limit to the up and down. So limit x approaches to 0, cosine x over limit x approaches to 0, this is sine x over x. And by the way, this is by the note, this is equals to 1. This is equal 1. And if you apply the limit for cosine 0, so what happened here? This is equals to cosine 0 over 1. Cosine 0 is 1, 1 over 1 is 1. So this is the final answer. Now the next one here, I have this x power 2. Limit x approaches to 0. So I will write it here, sine 3x and then over x. And then here I can apply limit x approaches to 0, sine 5x over 5. But we cannot use the rule. Why? There is a same term should be there. Here 3x, it should be 3x here. So if you divide 3x, I have to multiply 3. Now similarly, here you have a 5x, but in the denominator only x. I have to divide by 5. So therefore you have to multiply 5 here. So as per this rule, so this one is equal 1 and this one is equal 1. So final answer will be 5 times of 3 into 1 into 1. So which is equal 15. Thank you.